That's the plan, Michael. Okay. So this is a lot, and I ran out of room, so I'm gonna just stop there. Um, but I'll go through it as we go. So the way this works, as long as this isn't a whole bunch of other people that I've taught before, um, I'm I usually put kind of the a broad thing of notes up on the first screen. Then we start and we just kind of go through one by one how to do each problem. And it's not meant to be reteaching unless like everyone doesn't understand it. But it's meant to be a reminder of what we've done in the past and how to do those problems and what I'm expecting. Okay, so as you kind of walk through this, or as we walk through this together, just let me know if you have questions. Just post it or email me or whatever, um, and I'll do my best to kind of keep an eye on it. Um, Two things: the practice tests that we did in class, the answers to those were emailed to you. They're also in on campus. This is this one that I'm about to do is also in on campus. It's just labeled differently, and you'll kind of look at it and you'll see it. Is this going to be posted? Yeah, this will be posted as soon as this is over. Uh, I would keep this link because sometimes it doesn't show up like immediately, um, but it should within like an hour or two. Okay, so if it's 10 o'clock or something, you're trying to last minute study, it should be up by then. I just can't guarantee it based off of whatever YouTube does. Um, but yeah, this will be up after. Okay, so just a couple things before we actually start it. Um, Distance formula, midpoint formula, what intercepts actually mean. Symmetry, equations of lines, circles, inverses, vertical and horizontal line tests, and parallel and perpendicular lines, as well as transformations, which is where I started to run out of room. Um, but you should all have those in your notes, and they're also all in the book. So if push comes to shove, if you really need to go back and look at those notes, like specifically, go back to the book. I think that was like 1.6 and 1.7. But they'll be there for you, okay? And then I can always answer any questions we have. I'll try and do this transformation stuff. I'll try and put like the broader notes of these as we get there, okay? So I'm hoping as I was writing this, people were like looking and all that stuff. But if you want to pause it, look at this stuff. It's not everything, but it's most things. So what I'm going to do, I'm going to scroll down. This is a regenerated version of the test, and we're just going to go through this step by step about what I'm expecting and how to do it. Okay. So number one, 3 parts to this question. Okay. Label the points, find the distance, and then find the midpoint. Okay. So labeling points, this should be easy. This is something that you guys have been doing since probably like 7th grade. This first point, it's over 2, so -2, and then up 4, so -2, 4. This point right here, over -3, up 1. So that's the first part, right? If this is a 3-point problem, which will probably be more like 4 because the distance is going to be worth 2 points. This is one of them, okay? And then the distance between these 2 points, keep it in mind, the equation that I had up above. This is the difference of the x's squared, so -2 minus -3 squared, plus the difference in y's in the same order, so 4 minus 1 squared. Okay, then we simplify. -2 plus 3, that's 1. 1 squared is 1. 4 minus 1 is 3. 3 squared is 9. So this is going to be rad 10. Okay, so that's what I'm expecting for the distance. Midpoint, this is the average of the x's, so -2 plus -3 over 2, comma, average of y's, so 4 plus 1 divided by 2. So -5 halves and 5 halves should be your answer. All right. Same thing for the other one. So over 3. So this is -3, -1. Bottom point is 2, -5. Then we find the distance between these. So difference in x's, -3 minus 2 squared, plus -1 minus -5 squared. So then it's being 25 plus 16. So this is the square root of, God, I have to do math. Square root of 41. There it is. So this is our distance, midpoint. This is the average of the x's, so -3 plus 2 divided by 2, comma, -1 plus -5 over 2. And this is equal to -1/2 and -6/2, which is -3. Does it matter the order you put the x's? It doesn't, so long as you do the same order with the y's. All right, so you can calculate distance both ways, right? You can do x2 minus x1 squared plus y2 minus y1 squared. Or you can just change the order of the x's, right? It shouldn't matter. It doesn't matter. Oh, that was bad. So you could do x1 minus x2 and y1 minus y2. Right? The only thing you have to keep in mind is that whatever order you do one of them in, you have to do the same order in the other. So if you go 2-1, then you have to do 2-1. If you do 1-2, then you have to do 1-2. You could also do the y's first. It doesn't matter what order you add. And in this case, it doesn't matter what order you subtract so long as it's consistent because it's all being squared. Okay, so that was the first two questions. Again, these should be relatively easy on the first page. Identify the center and radius of each. So if you remember, the equation of a circle is x minus h squared plus y minus k squared is equal to the radius squared, where hk is the center. So in this case, our h is 2 rad 17. And our k is rad 238. Our radius, okay, so our radius squared is 4. So our radius is just 2. And then we're done. Same thing over here. Center is 11.7. Right, it's centered at that point. And then our radius squared is 16, so our radius is 4. Also, just as I forgot to mention this, I think I mentioned this in class. Usually, like every step is a point. Okay, so like these circle questions are usually worth 2 points. These number 3 and number 4. The ones up above it, identifying the points, that's 1 point. Finding the distance, that's probably worth 2. And then finding the midpoint, that's probably worth 1. So each of those are worth 4. Okay. So it's normally like the number of steps you have to take, then that's the number of points it is. So 3 and 4 are pretty straightforward. 5 is a little bit more difficult. All right, we have the center and a point on a circle. All right, so the center is hk, so h is 9, k is 17. Is there any work we need to show for those? Like, no, I don't think so. I think it's just identification, which is not, yeah, I'm not expecting work for those, number 3 and 4. It's just, again, you got to know the equation for it. Number 5, 917 is hk, okay? And then we're given a point, 717, okay? So if we think about a circle, I'll draw it real quick. Okay, if this is 917, this isn't exact. We have another point, 717. Oh, doesn't matter. Could be anywhere. Okay, so what we have to do is we have to find the distance between these 2 points, and that gives us the radius. And once we have the radius, we can plug it into our equation, and then we're done. So what we need to do, and in this case it isn't hard, but I'm going to do this anyway. I want to find the distance between the point on the circle, and the center. So difference in x's, 7 minus 9 squared, plus difference in y's, 17 minus 17 squared. Again, this probably doesn't require this much, but just so we see it. 7 minus 9, that's negative 2. Negative 2 squared is 4. 17 minus 17 is 0, so we just have the square root of 4. Okay, so this is our radius. It's just 2, right? Either one. So our center, our equation of a circle is x minus h. In this case, that's 9 squared, plus y minus k, which is 17 in this case, squared, is equal to the radius squared, which is just 4. Okay, if we're wondering about the work I'm expecting, it's finding the radius or it's finding the center. All right, it would probably just be a find the radius type of question. It probably won't be as straightforward as giving you a point that's on the same height, right? But you'll have to find the distance in some way. Okay, next up is lines. And I think that brings us to the end of part 1. Yeah. Okay, so lines, I don't care what type of equation you use so long as it's right. All right. You will most often probably use this because this is what you're most used to. But I'm okay with point slope form because it's easier and just way more efficient. Okay. And we also need to know slope. Right, so all this is just algebra 1 stuff. So we have a point and we have a slope. Okay, so I'm going to put this in point slope form first. So this is going to be y minus y1. So y minus negative 3. So y plus 3. And that's going to be equal to our slope times x minus x1, which is x plus 2. If you just get here, you're good. Okay, that's an equation of a circle, or not a circle. That's the equation of a line, which is really all I want. If you choose to do y equals mx plus b, what you would do is you would plug in your y, you would plug in your slope, you would plug in your x, and we would solve for b. So if we do that, negative 3 is equal to negative 4 plus b. So b is equal to 1. So then we have y is equal to 2x plus 1. Okay, if you simplify the left equation, you're going to get the right equation. That's why it doesn't matter which one you do, they're both right. Okay, given 2 points, the first thing we should always find is the slope. So if we do y2, we can label these first, x1, y1, x2, y2. So we do y2 minus y1, so negative 5 minus 0 over x2 minus x1, so 5 minus 3. We get negative 5 over 2. So that's our slope. Okay. After this, again, you can do whatever you want, so long as it's correct, right? What I would do is I would use point slope form. Right, so if I just write that again, after that, all we're doing is plugging in numbers. So we do y minus 0 is equal to negative 5 halves x minus 3. If you do slope-intercept form, again, you would just pick one point. So we could pick 0 or negative 5 is equal to m times our x value at that same point plus b. This is going to be a fraction, so this is 0 is equal to negative 15 over 2. So b is 15 halves. So then we have y is equal to negative 5 halves x plus 15 halves. Either one of these will do. And really, there's even more answers than this, right? We could have used our second point as well. But again, it's just up to you. Okay. Parallel and perpendicular. All right. Parallel lines have the same slope. Perpendicular have opposite reciprocal slopes. And then we're just using equations and points and that, and we have our answer. Okay, so again, if I use point slope form, we would get y minus 3. We want parallel, so our slope is going to be the same. So that's negative 6, and then x plus 1, and then we'd be done. Okay, again, you can use slope-intercept form. It's just simplifying this, but it's up to you. All right, so we could do 3 is equal to negative 6 times negative 1 plus b. So b is negative 3. Therefore, we have y is equal to negative 6x minus 3. Again, either of those will work. And then the same thing up here, except this case we're dealing with perpendicular. Our slope for this line is negative 1. So our new slope is negative 1 over negative 1, which is just 1. Right, so we would do y plus 4 is equal to 1 times x plus 2. Or we could do negative 4 is equal to 1 times negative 2 plus b. We solve for b, and then we plug in. Okay, so that's part 1. This is all just a review of really Algebra 1 with a little bit of geometry. So it should be pretty straightforward. Just a lot of lines and circles, right? So on to part 2. Okay, so state if the given functions are inverses. If functions are inverses, then f of g of n in this case is just going to be equal to n. Right, so if you compose the two functions together, you should get just n. Right, so if we do that, f of g of n is going to be equal to 1/7 n, right, 1/7 times the input, which in this case is 7n plus 4, and then minus 4/7. Right, that's those two functions composed. So we get n plus 4/7 minus 4/7, which is just equal to n. So then f and g are inverses. I think that's all the direction. Yeah, okay. Number 2 and 3, state the domain of the given function, then find the inverse, then state the domain of the inverse. That's the one direction I missed. Okay, so in order to do this, we're going to rewrite this as y is equal to 2 over x minus 1 minus 1. We are going to swap variables. And then we're going to solve for y. Right, so in this case, we'd add 1. We need to flip everything. And then multiply by 2. And then add 1. And then this is our inverse. Okay, but I forgot to take the domain. So the domain of g, right? In this case, x can't be -1, or it can't be 1, because that would make that denominator 0. Okay, so that's part 1. Part 2 is all of this. And then the domain of this function is x can't be -1. Right, again, because that denominator, if we plugged in -1 into that denominator, we'd get 0, and we can't have that because that's undefined. All right, number 3, we're going to do the same thing. I'm going to do this the way I showed you originally. Both work, so we could still swap variables, solve for the other one. But we could also do is we could just list operations on n. Reverse the order and invert the operation, right? So the first thing that happens to n is we add 1. Then we take everything to the 5th power. Then we add 3. So our inverse then, our first would be subtract 3, 5th root, and then subtract 1. Right, so if we do that, we'd have x minus 3. We would take the 5th root of that, and then we'd subtract 1 from that. So then this is our inverse. And again, I didn't list the domain. In this case, domain, we can plug in anything into n. So n is just all real numbers. Then we find the inverse, which is this guy, right? And then we have to think about what are possible x's that we can plug in. It turns out this is also all real numbers, because we can take the 5th root of anything, right? Even negatives. If it was a square root, that'd be a little bit different. We can't take the square root of negatives, but we can take an odd root of numbers. So that's the inverse part. I'm going to pause there and make sure no one has questions, and then we'll get going in like 20 seconds. Why is it all real numbers? I'm assuming you mean... Well, I'll explain both, but first, the domain of this function, right? We can plug in any number we want into n. There's no illegal numbers, because we can, right? If we have any number, first of all, we can add 1 to any number, right? And we can also take that to the 5th power. There's no numbers that we can't add 1 to it and take that to the 5th power. So that's why that's all real numbers. And then we can always add 3 to any number too. So that's this. That says that n can be anything. As for the 5th root, of x minus 3. Think about cubics. All right, so cubics look a lot like that. Okay, we can take right, when we cube negative numbers, we get a negative number. So the same is true if we take the cube root of a negative number, we're also going to get a negative number. So that's totally legal. The same is true for a fifth root, and I'll probably try and make that a little bit more straightforward. But you can take, right, if you take any number to the fifth power, you're going to get the original sign. So if you take a negative number to the fifth power, you're going to get a negative number. If you take a positive number to the fifth power, you're going to get a positive number. So the same is true for fifth roots. Okay, so you can take a fifth root of a negative number and get a negative number back out. So there's no illegal numbers that you can plug in. You could also look at this on a graph. I can't do that right now. Well, I guess I could on Desmos. I would encourage you to try and graph this on a calculator and see why that's all real numbers. I probably won't give you something where you're taking a fifth root, though. I hope that helps. I know that doesn't quite answer your question, but basically, there's nothing that we can plug in that's illegal here, because we can take the fifth root of anything. All right. Number 4, 5, and 6, and then 7 and 8 and 9 all get into transformations, which I did not write down yet, so I'm going to do that really quick. The ones I'm worried about, the transformations I'm worried about, are translations, right? So we're going to kind of make subsets of this. So for translations, this is shifting things left and right or up and down, and that's it. Okay, so for translations, we have vertical. Right, in order to move something up or down, we add or subtract a number to the outside. Okay, so if we're adding, excuse me, so anything on the outside of a function that is up and down, anything on the inside of a function that's left and right. Okay, so this C, that's on the outside of the function, so it's up and down. Right, so for horizontal, and I'll write both of these out. This would be right C units. And this would be left C. Okay, so those are the translations. And the other ones we looked at are reflections. Right, again, there's vertical, which is about the x-axis, right? So we'd be going this way. We're making all of the outputs negative. And for horizontal, or y-axis, we are making the inputs negative. And when you combine those two, you get origin symmetry, but that's not what we want right now. Okay, so horizontal, that's around the y-axis, right? And then those are all the rules that I'm expecting us to know. Okay, so first thing I want us to do is I want us to identify the parent function. I want us to tell me the translations, so left and right, up or down, and then tell me the reflections. Okay, so for number 4, right, we see this -2. Well, first, okay, so parent function, that's f of x is equal to 1 over x. there is a -2 inside the input. So that means we are shifting right 2 units. Okay, so this part right here, that means we're moving right 2. And then there's a negative on the outside of the entire function, which means we are flipping the entire thing upside down. Okay, so we have this 1 over x, right? So 1 over x, if we remember, looks something like this. So we need to shift that right 2 units. And then move it upside down. So our graph is going to look like this. Right? Not perfect, but it's right 2 units. Okay, number 5, parent function is radx. The -1 on the inside means we are shifting right 1 unit. And then the negative on the outside means we're flipping everything upside down. So our graph, we go right 1, and then we shift everything upside down, so our graph is going to look kind of like this. And if you want that help, you can always graph this on a graphing calculator, but I still want you to actually tell me what their parent function is and then describe the transformations, right? So parent function right here, describe transformations, and then graph it. Okay, number 6, our parent function is absolute value. The +2 on the outside means we are adding, we're moving 2 up. And then the negative on the outside means we're flipping everything upside down. So our original graph, if you remember, looks like this. So we need to shift that up 2 units and then move it upside down. So our graph is going to look kind of like this. And I'm trying to be accurate, but I'm not very good at it freehand. But I think we get the point. All right, so this is our graph. That's it for transformations. No, just kidding. No, it's not. Number 7 and 8 and 9, it's similar, but we're working backwards. Okay, so again, a couple parts. We want to identify the parent function. We want to describe the transformations, and then we need to write an equation. Okay, so very similar to the things up top, except we're working from the graph instead of the equation. Okay, so first thing, we have to identify the parent function. Number 7, the parent function here is radx. Radx is being moved to the right 3, and then it's flipped upside down. So then our function is going to be f of x and then +3, and then we're making that f of x negative. So our function then is negative square root of x +3. And then that's our answer. For number 8, our parent function is x squared. This is being shifted up 3. And then again, this is upside down as well. So then our function would be f of x +3, and then we need to shift it upside down, so there's a negative out front. So this is going to be negative x squared, and then +3. Number 9, this is a cubic. This is down 1. And it's being flipped upside down or left to right. I'll do left to right just to show us this, because this will most likely show up. Okay, so our function then is f of negative x minus 1, which is going to be negative x cubed minus 1. And then if you simplify that, that's just going to be negative x cubed minus 1. Okay, it's going to be the same thing if you make f of x negative. You're going to get the same answer. So I want to pause there after transformations, make sure no one has any questions, and then we'll move on. Yeah, you're right. I was shifting it upward, so this should be this. And this should be negative then too. Good catch. Sorry about that. Okay, on to the next couple. These are the composition functions. So this is where uh, we're combining two functions in different ways, right? So on number 10, we're adding two functions together. On number 11, we are dividing two functions. Number 12, we're multiplying two functions. And number 13, 13 and 14, we're composing two functions together. Okay, and then after that, we've got a lot more. Okay, all right. So number 10, this is simple. All we're doing is we're adding f of x and g of x. So what we do, and I think these are the same. I believe they are the same, but I'll do them anyway. We can just go through them a little bit quicker. Okay, so if we are adding two functions together, this would be f of x, right? So that's f of x, and then plus g of x, and then combining like terms. So we have 3x squared minus 2x minus 1, and then that's our answer. On number 11, that is f of x over g of x. Okay, and really that's what like. This is the actual combination of those two things. But if you look closely, you can factor this and factor the bottom. So then we have x minus 1 over 2x plus 2. So that would be like a full answer. If you just did the thing above, I'd probably give you credit, but I wouldn't give you everything. I would like you to simplify as much as you can, because this is going to be something we're doing a lot later on. So any chance I have to say, oh, factor this and then simplify as much as you can, I'm going to take it. Okay. Number 12, we're multiplying those two functions together. So this is going to be x squared minus 2x plus 1 times 2x squared minus 2. Okay, and this is just FOIL, basically, right? So x squared times 2x squared, that is 2x to the fourth. X squared times negative 2, that's minus 2x squared. And then we're just doing that for all the other terms. So negative 2x times 2x squared is negative 4x cubed negative 2x times negative 2, that is plus 4x. 1 times 2x squared is plus 2x squared, and then minus 2. And then we combine like terms, so we've got 2x to the fourth, minus 2x squared and 2x squared cancel. We have minus 4x cubed plus 4x minus 2. So I believe I did all of that right. So we're just, it's kind of like mega foil. Okay. Composing the two functions together, right? We're taking g as the input of x, or yeah, as the input of f. So this is going to be 2x squared minus 2 squared minus 2 times 2x squared minus 2 plus 1. And then we'd FOIL that. And then combine like terms. So 2x squared times 2x squared, that's 4x to the fourth. And then minus 2x squared minus 4x squared. Minus another 4x squared, and then plus 4. Minus 4x squared plus 4 plus 1. So we get 4x to the fourth minus 8x squared minus 12x squared plus 9. Yeah, I believe that's it. And then we go the reverse way. Okay, so x squared minus 2x plus 1 and 2x squared minus 2. Okay, so for the other one, we do g of f of x. So now f of x is the input to g. So this is going to be 2 times f of x squared minus 2. And then we just have to FOIL that. So we get x to the fourth minus 2x cubed plus x squared minus 2x squared plus 4x squared. That should be a cubed. Minus 2x plus x squared minus 2x plus 1. So this is x to the fourth minus 4x cubed plus 6x squared minus 4x plus 1. Okay, so that's all the combination of functions. Okay. Number 15, determine whether or not the following points are vertices of a right triangle. So these are 3 points. And what we have to do is we have to test whether or not they create a right triangle. Okay. So in order to do that, we have this thing called Pythagorean theorem that says that for a right triangle with hypotenuse C, and other sides a and b, that a squared plus b squared is equal to c squared. So what we need to do is we need to find our c, we need to find a, and we need to find b, and then plug them into Pythagorean theorem and see if it works. Okay, so we need to find the distance between these 2 points, these 2 points, and these 2 points. Okay, again, this wasn't changed. I don't think 15 or 16 were changed. spelled this wrong. Anyway, so we're going to find the distance between point 1 and point 2. So this is going to be 5 minus 3 squared plus 7 minus 5 squared, which is equal to 4 plus 4, so that's right 8. The distance between point 1 and point 3, so 0 minus 3 squared plus 9 minus 5 squared, 9 plus 16, that's 25, so this is just right at 25. And then the distance between point 2 and point 3, so 0 minus 5 squared plus 9 minus 7 squared. And this comes out to 25 plus 4, so this is rad 29. Right, so the biggest one of these is C, which is this guy. So that's C. We can call this A. We can call this B. So A squared, that's 25. B squared, that's 8. That does not equal C squared, which is 29. Therefore, this is not a right triangle. Symmetry. So I have this above. For symmetry about the y-axis, we need to test if f of x is equal to f of negative x. So all we're doing now is we're plugging in negative x into this function. So if we do that, we get 1 over negative x squared plus 1, which comes out to 1 over x squared plus 1. This is equal to f, therefore there is symmetry about the y-axis. I'm spelling things wrong. X-axis, we are testing if f of x is equal to negative f of x. So if we do that, we just throw a negative out front, which is equal to negative 1 over x squared plus 1, which is not equal to the original. So this is not x symmetric. And because it's not x symmetric, but it is y symmetric, this is not origin symmetric. But we can also test that. So origin, we are testing if f of x is equal to negative f of negative x. So we get negative 1 over negative x squared plus 1, and that's still equal to negative 1 over x squared plus 1. So this is not y symmetric, or not origin symmetric, I'm sorry. I am not going to do these next couple because this is just using a calculator. Okay, I will most likely reduce this on the test to 2 or 3, depending on how big the actual problems are. But this was, as I was doing this is kind of ridiculous to do. It just took too much time and it wasn't really worth it. So there will probably be 2 of these on the test. And these answers are on the answer key. But basically, you're graphing it on a calculator. You go to second trace, you find the zeros, go to second trace again, you find the maximums, and then go to second trace again and find the minimums. None of which I can show you on this because it's not on my computer. Okay, and then lastly, number 22. So this is a problem we tried a lot in class. It seems like we all got it, but I just want to do it to make sure. Okay, f of x plus h. So we're finding f of x plus h minus f of x all over h. In this case, f of x plus h is 4 times x plus h squared. minus 3 times x plus h, which is equal to 4 times x squared plus 2xh plus h squared minus 3x plus 3h. So we get 4x squared plus 8xh plus 4h squared. There should be a squared there and not right there. Minus 3x plus 3h. We want to subtract f of x. Okay, so if we do that, we get 4x squared plus 8xh plus 4h squared minus 3x plus 3h minus 4x squared plus 3x. This is all over h. Things that cancel. 4x squared cancels negative 4x squared. Negative 3x cancels 3x. And what we're left with is 8xh plus 4h squared plus 3h over h. A lot of things have nh in common, so if we factor that out at the top, you're left with 8x plus 4h plus 3. H's cancel, so our answer is 8x plus 4h plus 3. Okay, that was really fast. I'm going to pause and make sure we all got that. Okay, as we are maybe coming up with questions, shouldn't it be negative 3h on top? No. Yes. No. No, yeah, you're right. It should be negative 3h. You're right. So then this should be negative. Which means this is negative, this is negative, and this is negative. Yep, you're right. So, as you're looking at this, because this just went an hour, and I didn't realize we went that long. I'm gonna scroll up, kind of scroll down slowly, and if there are no questions in the next like 5 minutes, so like by 8:39, I'll call it, and we'll call it a day. Okay, so I'm gonna mute myself. I'll kind of slowly scroll from the top down, and then as you have questions, let me know. If there are none by 39, we'll call it a day, and we'll see you tomorrow. Okay, so I'm gonna mute myself and scroll down. All right. It doesn't look like anyone has any questions. Um, so in the next like minute or so at 8:40, I'll call it. If you do have questions, I am. You can email me tonight if you want, or you can come in tomorrow morning and ask for help. Um, I believe it's the last period of the day tomorrow. Okay. So if you have questions, make sure to come in. Um, if you keep this link open, you can rewind and pause. I'm not sure exactly when the entire thing is going to be up. It shouldn't be too long, but I just can't. I don't have any control over when it is actually up. Um, that is a very good tip. Don't fall asleep in class. No one has done that yet, I don't think. Not in that class. So that'll be good. All right. So thank you if you are watching, and I will see you guys tomorrow.